only a refresh for all of the students before we proceed to the much more advanced circuit analysis. Okay, this is the lesson outcome. So at the end of this topic, students should able to replace series or parallel combination of resistances by equivalent resistances, and then determine the current and voltage of circuit by combining resistance in series and parallel. Okay, this is a basic series resistance in a series circuit. So as you can see here, there are three elements of resistance, which is resistance 1 and resistance 2 and resistance 3. Then this is the current flow through this circuit, and before and it flow through a voltage 1, voltage 2, and it flow through the resistance 1, resistance 2, and resistance 3. So when the current flow into the each of the resistance, there will be a voltage drop. So the voltage drop, there will be a voltage drop at V1, V2, and V3. And the voltage must be less than the voltage from the voltage at power supply. Okay, from this series circuit, we can write and we can determine the voltage at V1, V2, and V3. So okay, I need to write something. Let me present. Okay, so this is a series circuit. Okay, from this series circuit, we can write a simple equation that related to a voltage, resistance, and current. Okay, we know that the current I is equal to I at resistance 1 equal to I at resistance 2 equal to resistance at I3. And then for resistance R equivalent, okay, is equal to R1 plus R2 plus with R3. Okay, and then plus with Rn lah, R at infinity. And then for voltage V supply or V total is equal to V1, the voltage drop at V1 plus voltage drop at V2 plus the voltage drop at V3 plus with the voltage at Vn. Okay, this is the equation that can relate to the series circuit. Okay, and then we also have a parallel circuit. Okay, actually student tak berapa memberansangkan sebab we based on the my system, supposedly we have 26 student. Okay, now we only have around 18 student. Okay, 19 is include me. Okay, if I'm not mistaken lah. So there must be around 6 to 7 more student. Okay, so just to make sure that everyone can access into this lecture, so I will upload this video into the YouTube. Okay. Okay. This is what I already explained to all of you. Okay. Therefore, a series combination of resistances has an equivalent resistance equal to the sum of the original resistance. Okay. So that is R equivalent equal to R1 plus R2 plus R3 plus with the Rn. Okay, and then we have a parallel resistance. For parallel resistance, okay, there is a voltage supply, and then the current will flow through resistance 1, resistance 2, and resistance 3. Okay. For parallel circuit, I always ask my student to imagine that the current flow is like a river flow. So when there is a junction, okay, or when the river of flow somehow split into two, okay, the uh, the current that split, okay, will be equal to the current from the current source. Okay, similar to a river. Okay, when the flow is split into two junction, okay, then the river of the flow will must equal to the flow um from the source. Okay. Okay, which is in this case for the current, it is equal to the current at I lah. Okay. Okay, in this case, from here we can write equation, okay, for a parallel circuit. There is a voltage supply, and then okay, this is R1, R2, okay. So for voltage, V total, okay, okay, you cannot take a V total, but what you can have here is V1 is equal to V2 equal to V3 equal to Vn. Okay. And then for current I is equal to I1 plus with I2 plus with I3 plus with In. Okay. And this is because of the current flow, okay, from based on the Kirchhoff current law. So basically, Kirchhoff current law state that the current entering the node is equal current leaving the node. So in this case, actually the current is leaving the node. So that's why you will have the current is basically the sum of the all current will be equal to the current from the current source. And then for the resistance, okay, 1 over R equivalent is equal to 1 over R1 plus with 1 over R2 plus with 1 over R3 plus with 1 over Rn. Okay. Okay. And then okay. Okay, so okay, this is the somehow the derivation once you need to determine the R equivalent. Okay. Network analysis using series and parallel equivalent. An electrical network consists of circuit elements such as resistances, voltage source, and current source connected together to form a closed path. Okay. So all of these elements somehow are connected together, and this connection somehow form a closed path. Network analysis is the process of determining the current, voltage, and power for each element. So basically, once the electric is flowing through the resistance, there will be a voltage drop, and as well as there must be a power, okay, that is consumed by the element. So which is I already discussed with all of you during the previous previous lecture. Okay, let us do this simple example. Okay, let all of us do this simple example. Okay, all of you can do this together with me. Okay, this is okay. I name this as node A, and this one is node B. Okay. Uh, Now we can draw a straight line. Okay, that consists of this node. So this is node A. This is node B. Then it goes back to the negative. This is positive. This is negative. Okay, and then we somehow have in between node A and B a parallel circuit. Okay, in this case, the parallel circuit is R3 and R4. Okay, here is R1, R2, and R3 and R4. Then it return to negative, negative power supply. Okay, from here, first we simplify R3 and R4, which is 5 plus with 15. And then you will get a 20 ohm. Okay. And then R2 is parallel with R3 and R4. Okay. So here 20 with 20 over 20 plus 20. Okay. How much do you get?
Sir, bukan R3 tu bukan ke tepi dekat dengan lebih dekat dengan node A. Sebab saya lukis sebelah-sebelah R3 dengan R4
Ya, tapi kan ni kan dia directly ni, dia straight.
Oh sebab dia series Oh, okay.
Dia series. R3 and R4 is a series. Okay, and then
okay.
R2 is parallel with R3 and R4.
Okay, faham. Alright, thank you, sir.
Okay. Okay. So I hope all of you can understand my why I make this R3 and R4 as a series connection. So you will have a 10 ohm. Okay. Then from here you already simplify a circuit. So the final is not the final. Basically you have here, then you have here, then you have a positive negative. So from here basically it is a series circuit. Okay, so here is R1, then this part is R2 parallel with R3 and R4. Okay. So for a series circuit, you can directly plus, okay, which is equal to 20 ohm. Okay. Okay. Now we proceed to the second example, which is this part. Okay, now I would like all of you try to do on your own. Okay, this is node A, node B, node C, and node D. Okay, try to do on your own, and I will try my best to supervise. Yeah, I give you 3 minutes. Okay, so from here you can draw a straight line. Okay, this is R1. Okay, then this is RAB, AB, AB. Then there's C, A to C. There will be okay, and then there's also D. Okay, then it goes back to the negative. Okay, this is A, B, C, D. So there's one element of resistance in between A and C. So this is R2. Then in between B and D, okay, okay, for B and D, Okay, we need to rearrange this circuit, okay, so that it can go directly. Okay, this is A, R1, okay, from A to C, okay, A to C, okay, and then B to D, uh, C, wait, hmm. A, A to C, okay, B to D, there is 3 ohm, this R3, then this is R2, okay, then you also have another circuit which is parallel to R3. Here you will have R4. Okay. Okay. So from here, what you can do is to uh, parallel this R3 and R4, which is equal to divided with 5, 1.2 ohm. Okay. Then okay, from here it is basically parallel with R2. Okay. Now you have R2. Okay. Then you have one more here. Okay. Now this is 1.2 ohm. Then R2 is 6 ohm. Okay. Equal to R2 parallel with R3 and R4. Okay. You will have 1 ohm. Okay. So the final circuit will be, then this is the R2. So here it is a series circuit, which is R1 in this case is 2 ohm, 2 plus with 1 equal to 3 ohm. Okay. Okay, 3 ohm. Cuba kita plus with 3. 3. Okay. We will get a 3 ohm. Now we proceed with the third example. Okay. Here you write it as node A, B, and node C. Then you draw a straight line consists of node A, okay. Then in between A and B there will be one resistance, which is 8 ohm. Okay, I write it as resistance R2. Okay, and then B to C. B to C there will be one resistance. Okay. Okay, now B to C 6 ohm, and then there also another one line of connection between B and C. So it is basically in parallel. Then it go to the negative power supply voltage. Okay. Okay, now you have R2, and then this is R3, R4. Okay, then you also have another A to C. A to C. So you can draw another one A to C, which is R1. So in this case, first you parallel R3 with R4. Okay. Then after you get parallel R3 and R4, you series R2 with R3 and R4. Okay, this is the first step. Second step, and then third step is parallel between R1 parallel with R2, R3 parallel with R4. Okay, then R2. Okay, yeah, that's all. So this is the final answer, which is a combination of parallel circuit of R1 parallel with R2 series with R3 parallel with R4. Okay. Okay, try to solve. I give you 3 minutes. Okay. How much do you get for the final answer? R equivalent? Anyone? Or should I call you by name? Iskandar Ashraf. Berapa
Dah.
kamu dapat untuk R equivalent?
5
5
ohm.
ohm yang lain dapat 5 ohm juga ke?
Dapat sir.
Okay, 5 ohm I think the exercise is not too difficult. Okay. Try to solve this on your own. I give you 4 minutes. Okay. Salin saya nak switch off. Tempat salin ke?
Tak sir.
Okay,
Tak, sir.
Okay, salin kejap Yeah, I believe you already copy the question. Stop.
Saya tak sempat sir.
Tak sempat juga.
Sir dah sempat.
Enggak.
Biar buka boleh sir.
Tak boleh sebab ada benda lain nak kena buat kejap.
Okey, jap. 2 minit,
Ah.
2 minit sir.
Okay. Set timing bukan yang ni kan? Sekejap. Okay, yang ni. Okay, so for this part, I will discuss with all of you how to solve this circuit. Okay. Okay, first from here, okay, this is node A, node B, node C, and node D. If you draw a flow of current from the positive to negative, okay, there will be a node A, okay,
Um,
in
Maaf,
yeah.
saya ada tukar slide ke sebab saya dapat benda sama je ni?
Dapat benda sama.
Ah.
Ni dapat ni kan ada ni soalan ni. Betul?
Betul, ingatkan saya tengah lukis sekarang ni. Sorry.
Oh, sekejap. Saya rasa saya tak on ni. Sekejap your entire screen. Okay. Sekarang nampak ni circuit yang saya lukis.
Nampak.
Okay. Okay, so antara node A dan node B ada satu resistance, okay. Then the resistance is actually in parallel. So the parallel circuit is consists of R1 and R2. Okay. Then it combined to one node, which is a node B. Okay, and then the current will flow to node C. Okay, node C. Okay, there is no element in between node B and C. Okay, and then the current flow to node D. Okay. Okay. However, in between node C and D, there is one element of R3. Okay. Then then go to node D. Okay, node D. Then node D will return to the negative. Okay. So this is V positive, this is V negative. Okay. In between C and D, there is also another resistance, which is R4. Okay, if we simplify the circuit, we will have a R3 parallel with R4. Okay. Then and R1 parallel with R2. Okay. And then finally you have a series circuit which is consists of two elements, which is R3, R1 parallel with R2, and then R3 parallel with R4. Okay. So this is a series circuit. So you just sum the so you just plus with R1 and R2 plus with R3 parallel with R4. Okay. I will ask one of you to give me the answer. Muhammad Amar, berapa dapat untuk R equivalent? Amar? Okay, Amar. Amar dengar ke? Dengar suara saya dengar ke? Okay, Amar nampaknya mungkin Amar ketandas. Okay. Shavinesh Suresh. 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 Akram. Akram Jamal.
Ada sir.
Okay. Okay, Akmal dapat berapa R equivalent?
52.8 ohm.
Ui. Biar betul 52 Akmal. 52.8 betul ke R equivalent?
52.08.
Sama ke? 5208 enggak?
Ha.
52.08 ohm.
Dapat sama rata.
Ha.
52.08 ohm.
Okay. Saya cuba kira Polimer. Sorry. 75 kalikan dengan 25 bahagi dengan 75 tambah 25. So sini saya dapat 18.75 100 kalikan dengan 50 bahagikan dengan 150. Okay, betul 52.08 22.08 ohm. Okay. So I will please take this as your assignment. Ni senang sangat ni Okay. Take this as your assignment I will upload in the Telegram.
Seberapa jawapan dia, sir?
Tadi
Kosong pun berapa?
52.08.
Tak dapat, sir.
Hah? Tak dapat 52?
Tak tahu salah kira ke salah formula.
Ni saya kira kan dengan sama-sama boleh saya tahu siapa yang bercakap tu?
Saya Fakrul Faiz.
Fakrul Faiz Okey Fakrul pertama sekali kita parallelkan R3 and R4.
Betul.
Okey. Jadi kita 75 kalikan dengan 25 divided 75 tambah 25. Ada orang baru nak join. Okey, Naziha baru join ke? So 75 kalikan dengan 25 bahagikan dengan 75 tambah 25 So dapat 18.75 ohm Akmal tahu tak kenapa saya boleh buat directly 75 kali 25 bahagi 75 bahagi 20, tambah 25 ni? Fakrul. Tahu kan?
Tahu.
Okay. Jadi sekarang ni yang kedua R1 parallel with R2. Okay, 150 divided with 100 plus 50 sama dengan bahagi dengan 150. So sini dapat 33.33 ohm So daripada sini basically kita akan dapat satu series circuit Okay. Kenapa saya dapat series circuit? Sebab dia dah simplify So sini R3 parallel with R4 and then kat sini R1 parallel with R2. So sini 33.33 yang ni 18.75 ohm
Saya dapat salah masuk nombor, sorry.
salah masuk nombor Tak apa, apa buat salah dalam kelas tak ada masalah
Maaf saya
Kelas
maaf.
is kelas adalah tempat untuk semua pelajar untuk buat mistake So don't worry if you make mistake. Okay. Alright, so now we proceed to the another type of circuit analysis, which is delta to Y conversion. Okay. For delta to Y conversion circuit, okay. Let me open my note. Okay. Okay. Untuk delta to Y circuit, basically somehow if you have a circuit connected in a triangle, okay, you need to remove one of the resistance. Okay, in this case, the element that we need to remove is RC. Okay, once we remove the RC, then we can determine the resistance that the resistance at in between the node. Okay, so this is the conversion from delta to Y. Okay, in order to determine the resistance at in between RB and RA, which is in this case is R3. Okay, this will be the formula, which is RA times RB over RA plus RB plus RC. Okay. Similarly for R1, which is in this case, it is considered as R1 in this equation. Okay. It is in between of RB and RC divided with the sum of RA plus RB plus with RC. Okay. And then similarly for RC, okay, RC, similarly for R2, okay, in order to determine R2, it is in between of RA and RC divided with RA plus RB plus with RC. Okay, vice versa, okay, let's say you need to determine the RA. So you will need to take the value of R1, R2 plus with R2 plus R3 plus with R3 times with R1 divided with R1. Okay. This is for RA, which is in opposite. Okay. Okay. This is the example. Okay. This is from Y to delta connection. Okay. If you can see here, this is a connection of a Y. Okay. If you okay, maybe it is not look like Y, but somehow if you bring this node NA and ND somewhere here, then it will looks like a Y. Okay, in this case, we need to transform the Y to delta transformation. So once you transform this circuit into a delta connection, so you will have a parallel circuit. So using the circuit analysis, it is much more simple for you to determine the equivalent. It is actually depend on the question. Okay. Now we try to solve one example. Okay. This is a case of delta to Y transformation. Okay, now we try to solve this exercise. Okay, in this case, as you can see, it is a delta transformation. Okay, So if it is in a delta form, you cannot directly determine the current or the resistance, sorry, the current that is flowing from this positive to the negative side. So in order to determine the current flowing through the circuit, okay, you need to eliminate the resistant element of RBC. Okay. So in this case, it is a delta to Y transformation. Okay. Let's do this together. Okay. Okay. Now you imagine there is a Y connection. Okay. The Y connection will be in between of the delta transformation. Okay. There will be, okay. 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 This one I will put it as RA. Okay. Then RB and RC. Okay. So using the formula that I already mentioned previously, you can determine the value of the represented resistance. Okay, I will call one by one your name. Okay, this is the formula. Okay. Okay, this is the formula. And then this is the connection. Okay, boleh nampak ke?
Nampak.
Okay, so ada RA, RB and RC. For RA, I will calculate for you. Okay, in this case, RA represent R3. So I look at the formula R3. Okay, it is RAB times with RAC divided with RAB plus RAC plus with RBC. Okay. Then I go to RBC. Sorry, RB. Okay, in this case, RB represent R1. Okay, now I look at the formula of R1. Okay, okay. So you just senang je sebenarnya. Dia antara RAB dan RBC. Kalikan dengan RBC. Divided with RAB plus RAC plus RBC. Okay, bahagikan dengan keseluruhan resistan pada circuit tersebut. Jadi sekarang ni kita RC, okay, RC in this case merujuk kepada R2. Okay, R2. Jadi R2 adalah RAC dan RBC. Divided with RAB plus RAC plus with RBC. Okay. So now calculate on your own. Okay. Saya nak panggil beberapa orang. Oh, tak sempat salin lagi tadi. Okay. So I would like to call Nazihah. Okay, Nazihah. Boleh saya tahu berapa value RA?
RA 0.83.
0.83. Okay. Nazihah guna value yang mana untuk dapatkan 0.
Oh ya. 12.
Ya,
RA tu saya guna 12.
guna 12, okay.
So RAC, RAB tu RAB times RA, times saya sebab tambah salah. Sorry,
Dia kat
sorry.
kena darab
Salah. Okay.
Okay.
Sekejap. Dapat 6.
Dapat 6, okay, betul 6 ohm
Okay.
Okay, thank you Nazihah. 6 ohm. Okay, for RB saya nak tanya RB. RB cushion. Cushion
Yes sir. Tengah kira sekejap.
tengah kira. Suresh. James. Apa khabar
Yang
James?
B ke?
Apa khabar? Baik Sudah
Ya.
makan?
B jalan 2.
Sudah makan belum?
B jalan 2.
Dua. Okey. Dua
Sama sir, saya pun dapat dua.
Okey, 2 ohm
Ya.
Okey. Okey, RC. Sekejap RC, saya nak panggil Intan Farzana.
Dapat 3 ohm sir.
3 ohm. Okay, so this is the answer Okay. Jadi sekarang ni kita dah dapat value RAB, RAC semua tu. Tapi kita sebenarnya tak habis lagi Okay, this is the 10 volt power supply. Okay. Sekarang ni lita adalah berbentuk macam ni Since kita dah transform kepada Y to delta. Okay. So this is the transformation from delta to Y. Okay, so now RA adalah represent 6 ohm. Okay, ini adalah RA equal to 6 ohm. Kemudian RB sama dengan 2 ohm. Kemudian RC sama dengan 3 ohm. Kemudian kita ada R4 and R5 12 ohm. Kemudian R4 adalah 18 ohm Okay, sekarang ni katakanlah I need to determine the current. Okay. First sekali kita ada voltage, current, resistance. Okay. Ini adalah resistance RA, RB, RC, kemudian R4 and R5 Okay. Jadi ini adalah basically application yang kamu belajar tadi, circuit analysis plus with the voltage, current and resistance relation So sekarang ni determine the current flowing into the circuit. Okay. I total So in order to determine the I total, okay, first sekali what we need to do is to parallel. Okay. RB series with R4 and then parallel with RC and R5. Okay. Nampak tak kenapa dia parallel? Okay, sebenarnya circuit ni dia berbentuk macam ni Kalau kita further kita nak bagi dia nampak mudah lah. Okay. Kadang-kadang dia circuit ni dia banyak trik je. Okay. Knowledge dia very fundamental tapi apa yang kita kena mahir adalah trik-trik dia. Apa-apa pun always refer kepada node Node is very important Okay. Untuk RB and R4 it is a series.
Sir, saya ada soalan sir.
Ya.
Boleh tak kalau nak tentukan parallel dengan series, kalau parallel dia kongsi dua node yang sama. Kalau
Parallel dia
series satu node yang
kongsi
sama. Dua node. Dua node yang sama. Sebab saya nampak macam tu.
Okey, tapi boleh jadi. Okey, ni kalau parallel parallel. Dia sebenarnya dia boleh, kalau series dia boleh jadi dua node yang sama juga. Contoh yang ni dia adalah dua node yang sama. Okey. Tapi dia akan berlaku parallel apabila kalau kita ingat balik kepada KCL okey, ni adalah dua node yang sama. Okey. Katakanlah ada satu junction daripada node A ke C. Okey. Jadi ni dah dikira sebagai satu parallel sebab dia dah keluar kepada, sebab dia dah current dia dah berubah. Current dia dah ke arah lain ataupun dah terpecah kepada node yang berlainan dengan node B. Jadi dia dah current tu akan jadi I total equal to, katakanlah ni I1 and I2. I total equal to I1 plus with I2. Okay. Current entering the node equal to current leaving the node. Jadi ini dah diconsider sebagai satu parallel ni antara AC dan AB. Okay. Kalau kita tengok yang ni RB and R4, okay. Walaupun dia ada 3 node tapi dia sebenarnya garis lurus. Okay. Dia just dia tunjuk circuit ni sengit tapi sebenarnya dia boleh jadi garis lurus. So it is a series circuit. Okay. I hope you can understand. RB and
Tu maksud saya sir.
Betul
Yang RB dengan R4 tu kan dia satu node kan, dia gabung dengan satu node kan. So saya consider dia series.
Okay.
Macam tu lah.
Series lah, betul lah ni series. Ni memang series. Okay. Sebab kita kalau kita assume current tu, memang current tu pada berlaku satu flow je. Dia tak ada flow lain
Alright sir.
So RB and R4 is a series circuit. And then okay, and then there's another resistance which is yang ni RC RC, R5, ini RE RE. Okay, so now we need to determine current flowing at RE. Okay, and then current flowing at RE must be a current must be a total current. So before we can determine the total current, we need to simplify the resistance and determine the R equivalent. Okay, first RB series with R4, okay, and then RC series with R5, okay, and then RB series with R4 parallel with RC series with R5. So now determine. So now calculate on your own. Okay. So so basically you will get RB and R4, which is 2 plus with 18, so you will get 20 ohm. And then RC and R5 is 15 ohm. Okay, now for the parallel, okay, you will get a value of 8.57 ohm. Okay, then RA is series with RB. Okay, RA is equal to 6 ohm. 6 plus 8.57. So it is equal to 14.57 ohm. So now determine the I total. So we know that V is equal to IR. The voltage supply is 10 volt. Current is I total. R is 14.57. 10 divided with 14.57. So you will get 10 divided by 14.57, 0.6863 ampere. Okay, that's you just solve one part. Now you have to determine the voltage at RA, RB, RC, R4 and R5. Now since you know that the voltage at RA is basically so now okay, now you know the current at I total flowing to the RA is 0.6863. So you can calculate the voltage, okay, at VA. Okay. Okay. Voltage at VA will be equal to 0.6863 times with the resistance. Resistance in this case RA is 6 ohm. 4.6 0.1178 volt. Okay. So you already have the value of voltage here, which is 4.1178. Okay. So what is the voltage at VB, VA, VB, VC, V4 and V5? So it must be voltage for VB plus VC plus V4 plus V5, okay, equal to 10 minus 4.1178. Okay. So 10 minus 4.1178 is 5.8822. Okay. Okay. So now we know the voltage at this part is equal to 5.8822. Okay. Okay. Now what next? Seven, eight. Okay. Okay. Now we know that the voltage in parallel is actually equal to each other. So basically voltage at this part and voltage at this part is equal to each other. So here V is equal to 5.8822. Then this one will be okay. So using this knowledge, okay, you can actually calculate the voltage at RB, RC, R4 and R5. Okay. Okay, now but first you need to calculate the current at RB and R4. Okay. So now voltage, okay, V is equal to IR 5.8822 equal to I, and then R is 20 ohm. So I equal to 0.2941 ampere. Okay. 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 So now we have the value of the current flowing at RB and R4 is 0.2941. Okay. And then at RB is sorry, R4. why I know the current flowing at RB and R4 is equal? Because it is a series circuit. This is a series circuit. Then now I calculate the current flowing at RC and R5. So the voltage is, we already have a value of 5.8822. Okay. Then we have the value of resistance. Okay. RC and R5 is 50 ohm. So I is equal to 5.8822 divided by 50. So you will get a 0.3922. Okay. So since this is a series circuit, again, so the current flowing at RC and R5 is equal to 0.3922. Sorry, this 2-1. Okay. This is RB and R4. Okay, RB and R4 current is 0.2941. Okay. Sini buka RA Jadi saya salah. Okay. This is 0.2941. Okay, current at RA kita dah calculate, which is equal to 0.6863. 0.6863. Okay. Okay, now for resistance, okay, resistance kita dah ada dah for each of the resistance. RA is 6 and then RB is berapa dah tadi RB ni? RB is 2 ohm RB is 2, then RC is 3, and then R4 and R5 is 18 and 12. 18 and 12. Okay. Jadi based on this equation, we can calculate the voltage. Okay. Now, voltage at B equal to 0. Okay, V equal to IR. 2 times with 0.2941. Okay. So you will get a 0.588. And then voltage at C. So you will get 1.1766 volt. Okay, and then voltage at R4. Okay, 18 times 0.2941. Okay, you will have a 5.299. Then voltage at R5. So 12 times with 0.3921. Okay. So 12 times with 0.3921. So you will have a 4.706 volt. Okay. Okay. So now, if you plus all of this voltage, you should get a equivalent of okay. Oh, okay, kita tak boleh. Okay, saya faham. Okay. So voltage 4.1178 plus with 5 point each of the voltage 5.88 and 5.88. Sorry, you plus this voltage and the voltage at this part, so you will get a 10 volt. Okay, you cannot directly plus like that. Okay. Okay, so any question before we
Sir, apa yang value 5.8822 tu untuk apa sir? Tak sempat tangkap tadi yang benda.
Orang dah siap habis calculate dah.
Dah klik semua lah. Cuma yang lain pun faham. Yang
Okay, dia macam ni. This is the circuit
Okay.
Power supply dia 10 volt. Okay. And then sini dia ada parallel circuit. Okay. Sebelum dia enter kepada parallel circuit tu, dia ada satu lagi resistor So basically 5.8822 ni adalah voltage selepas dia melalui resistor ni resistor 1 ni adalah resistor 2 and resistor 3.
Okay.
So voltage yang pada R2 and RT ni dia mestilah lebih kurang kan sebab dia dah melalui pada R1. Okay. Jadi since R2 and RT ni adalah parallel, jadi voltage remaining dia mestilah 10 minus voltage pada R1, betul tak? So that's why lah dapat 5.8822.
Okay. Alright, faham.
And then 5.882 ni dia sebenarnya merujuk kepada voltage 10 volt minus voltage pada RE.
Okay, faham.
Okay alright. Itulah penjelasan dia. Okay. Daniel. Okay, Daniel.
Yes, sir. Ya, ada.
Faham ke Daniel?
Faham.
Faham Alright. Uzi.
Yes sir.
Faham
Faham.
Afifah. Ada ke Afifah? Fifah hari ni tak datang kelas Okay. So, okay, kita akan proceed sikit lagi. Okay, try to solve this part Okay. Okay, cuba determine Okay. Determine voltage at R1, R2 and R3 and current at R1, R2 and R3. Okay, nak tutup kedai dah
Hello.
Hello ya, dah dapat dah voltage. Dapat dah voltage. Siapa yang bersuara tadi tu? Nak jawab voltage ke? Oh, pandai dia. Terus tutup speaker.
Tak ada saya.
Okay, Fakrul, berapa value voltage?
Tak dapat lagi rasa. Nak catch up.
Okay, dapat yang dulu
Ingatkan tadi lagging tadi sebab semua diam.
Itulah. Kadang-kadang saya rasa macam saya bercakap dengan dinding. Duk cakap tu seorang.
Ada sir.
Okay. Kalau face to face tak apa. Ni kita duk cakap depan slide. Okay, tak apa. Calculate dulu voltage, current dengan resistance. Sekejap ada orang call. Assalamualaikum. Ada kat office. Okay. So here what you should do. First, you need to simplify R2 and R3 to parallel with R3. So you will have a okay. 20 ohm 20 ohm. Lepas tu dia series series. So R1 series with R2 parallel with R3 which is equal to 10 plus 20 equal to 30 ohm Okay, now you calculate the current flowing to R1. Okay, so V apa pula? V equal to I R So voltage is equal to 90 and then I we need to and then R is 30. Okay, 30 so I is equal to 90 divided by 30. Okay, equal to 3 ampere Okay. So from here you can calculate the voltage. Okay. Okay, now we have the current flowing at 10 ohm which is 3 ampere Then the voltage is 3 times with 10 okay, which is equal to 30 volt. Okay, you will get a 30 volt. Okay, now the remaining voltage will flow to R2 and R3 and the remaining voltage will be 90 minus with 30 which is equal to 60 volt. So now you get the voltage of R2 and R3 which is 60 volt. Okay. However, in a parallel circuit, the current is not equal to each other because the current is split. Okay. So you again using V equal to IR, I is equal to voltage over resistance. Okay, the voltage is 60 divided by R equal to 30. So you will get a 2 ampere. So here is 2 ampere. And then for the 60 for the R3, I equal to 60 divided by 60 equal to 1 ampere. 1 ampere. Okay. So basically you can relate the current here flowing into R2 and R3 is split to this is 2 ampere. Okay. Then this one is 1 ampere. Okay. And then the current, the total current I total is equal to 3 ampere. Okay, that's all class for today.